Let f be a function in terms of two variables, x comma y, with n arbitrary constants, c1, c2, and so on, cn. Be a function in terms of x comma y variables with small n number of arbitrary constants. Small n number of arbitrary constants. What are the n number of arbitrary constants? C1, C2, C3, and so on, Cn. Okay, all these are n number of arbitrary constants. For example, I'm taking this one as equation number 1. This is equation number 1. Now, I'm going to find, if we want to find the differential equation of this function, then what we have to do is differentiate equation 1 with respect to x. How many arbitrary constants are there? How many arbitrary constants are there? N number of arbitrary constants are there. So that many number of times we have to differentiate equation 1. We have to differentiate equation 1 with respect to x n times successively. That means one after the other. If we do one-time differentiation, what we are going to get? If we do one-time differentiation, what we'll get?
First order will get.
Yes, first order derivative will get. X comma y comma dy by dx also will get. Because in general, we will feel y is in functions of x variable. So C1, C2, and so on, Cn is equals to 0. There may be a chance one arbitrary constants can go off, but this is, we are writing function in terms of, so we must write like this only. Okay, next, if we do one more time differentiation, what we are going to get? X, y, what we'll get? Dy by dx. Then what we'll get? Second order derivative also will get d square by dx square, comma c1, c2, and so on, cn is equals to 0. Take it as equation number 3. Okay, now again I am doing differentiation. Third term. If we do third term differentiation, what we'll get? F is a function in terms of x, y, dy by dx, d square by dx square, d cube by dx cube, comma, what are the arbitrary constants? Same arbitrary constants we'll get. We may get or not, but in general, we have to write like we will get it. So now I'm writing here first time differentiation. Now here second time differentiation, and then third time. If we continue like this, what we are going to get? How many times we have to do differentiation? N times we have to do differentiation. If we do n time differentiation, nth time I am doing differentiation. When we do nth time differentiation, what we'll get? F is a function in terms of x, y, dy by dx, d square by dx square, d cube by dx cube. Sorry, I mentioned here it is. Okay, and so on. Nth time derivative also will exist. Nth derivative of y with respect to x, comma, c1, c2, and so on, cn. Okay, this one only will get. What is the equation number? What is the equation number?
N plus 1.
N plus 1.
Yes, n plus 1th equation. So total, how many equations we got? First given equation number 1, and one time differentiation we got equation 2, second time differentiation we got equation 3, third time differentiation we got equation number 4, and the time differentiation we got n plus 1th equation. Okay, so now what we have to do is, again repeating, if the given equation contains first we have to identify how many arbitrary constants are there in the given equation. There are arbitrary constants, we have to do n time differentiation successively. Then we'll get n plus n equations. Then eliminate n arbitrary constants. What are the n arbitrary constants? C1, C2, and so on, Cn from, okay, by using these n plus 1 equations, eliminate n arbitrary constants C1, C2, C3, and so on, Cn. Then we may get like this. Then we get what is the equation we are going to get? I'm taking like this. G is a function in terms of x, y. What are that? dy by dx, d square by dx square, d cube by dx cube, and so on, nth derivative of y with respect to x. What about C1, C2, and so on, Cn? We'll get or not? We will get it or not? No, we will not get. Is equals to 0, because we have written here the point is as eliminating. Okay, eliminate an arbitrary constants C1, C2, and so on, Cn. This is very important step. So after eliminating, we are getting this the thing. So whatever we are getting is the required differential equation. Is the required differential equation. Required ordinary differential equation. So this is the way of a formation of ordinary differential equation. Now, if I am giving you a differential equation, sorry, a function in terms of two arbitrary constants, then we have to do differentiation 2 times differentiation with respect to x. Then from the given equation and the after doing differentiation of 2 times or differentiation with respect to x 2 times, 2 equations we'll get. From these 3 equations, we have to eliminate the arbitrary constant, constants to arbitrary constants. Then the reduced equation is called as differential equation of the given function. For the namesake, I'm giving here, okay, problems. Formation of ODEs for the following. Formation of ordinary differential equation. To the following functions. To the following functions. Following functions. Okay, so first one is I'm taking y is equals to cx plus x square. Cx plus x square. So what we have to take? What is the solution? Y equals to cx plus cx square. How many arbitrary constants are there? Taking this as equation number 1. How many arbitrary constants are there?
1.
1. Contains only one arbitrary constant. What is that one arbitrary constant?
C.
So how many times we have to differentiate? So differentiate equation 1 with respect to x. How many times? Only one time, because of one arbitrary constant. So if we do differentiation, what we'll get? Okay, instead of writing, okay, I'll write here dy by dx, but in future I may write as dy by dx as y dash also. Dy by dx equals to c is constant, differentiation of x is 1 plus differentiation of c square is, what is the differentiation of c square? What is the differentiation of c square?
0.
0.
0. So finally what we'll get here? Dy by dx equals to c. What is the actual procedure? After from the given equation and from the equation number 2, we have to eliminate arbitrary constant. So what is the step we have to write? From equations 1 and 2, eliminate c. Eliminate c. What is the, how to eliminate c? How we can eliminate c? Substitute
In equation
1. Substitute 2 in 1, then we'll get y is equals to x into, what is c? Dy by dx. So don't write it is as dy by dx into x. Okay, always write it is as x into dy by dx plus, what is c? Dy by dx whole square. Dy by dx whole square. So in this equation, do we have any arbitrary constant? Yes or no?
No, sir.
No. E is required ODE of given D. ODE of given function. Given function or given curve equation, or in any manner we can say. Now tell me, what is the order of this differential equation? What is the
One.
order of this differential equation? 1.
1.
What is the
One.
degree of this differential equation?
2.
2.
Now you check how many arbitrary constants are there?
1.
1. So order of the differential equation and arbitrary constants always equal. If the given function contains one arbitrary constant, then the corresponding differential equation order is also 1. Is it clear? For example, if you are having a function in terms of with the 5 arbitrary constants, then what is the order of the differential equation of that function? We are going to get
5.
5. Okay, so I'm going to give you, okay, I'll give you that point later. Now here I'm taking 1 or 2 more examples just for your understanding purpose. I'm taking here, any of you are having any doubts?
Sir, given function is y is
Sir,
equals to
question.
cx squared, sir.
Question tha process, sir.
Sir, you written wrong.
Yes, sorry. Yeah. Okay. Anyhow, I'm taking here it is x square. Thank you. This is x square. What is x square differentiation? 2x. This is 2x. Then what we'll get? C is equals to dy by dx minus 2x. Yes or no? That implies dy by dx minus 2x is equals to c. This one we have to substitute in place of c. So what is our equation? What is going to become? What is c into x? What is c here? Dy by dx minus 2x. X into dy by dx minus 2x plus x square. Okay, is the required ordinary differential equation. Of given function. Is it okay? Clear? Is it clear? Still any doubts? Thank you for the student who corrected the mistake. Okay, now no one is asking anything. Okay, then I'm going to the one more problem. I'm taking here Second one is y is equals to capital A into e power minus 3x plus capital B into e power 2x. Any of you can say what are the arbitrary constants here?
A and B.
A and B are arbitrary constants. But here, if they provide A, B are arbitrary constants, then only you have to take A, B are arbitrary constants. Otherwise, you should not take. So they will give in the problem, given y is equals to this thing, and given where capital A and capital B are arbitrary constants. If they gives like this, then only you have to consider as two arbitrary constants provided. Clear? Or arbitrary constants. Arbitrary constants. Now, how many arbitrary constants are provided in the given problem? Two arbitrary constants. So how many number of times we have to do differentiation?
2 times.
2 times. Okay. I'm writing direct step. 2 arbitrary constants. So differentiate equation 1. With respect to x, 2 times successively. So what is it? If we do one-time differentiation, y dash, I am writing just for the purpose, y dash equals to a into. What is the differentiation of e power minus 3x? Minus 3 e power 3x, this is the first term, plus b into, what is the differentiation of e power
minus 3x?
E power minus 3x.
Yes, e power minus 3x. What is the differentiation of e power 2x? 2 into e power 2x is the second term. Okay, writing it is as equation number 2. Again, differentiate it. So for the name's sake, I am writing here first time differentiation. So next, second time differentiation. When we do second time differentiation, what we are going to get? Y double dash equals to, y dash differentiation is y double dash minus 3a into. What is the differentiation of e power minus 3x? Minus 3 e power minus 3x plus 2b into e power 2x differentiation is 2 e power 2x. So with this, we are going to get as y double dash is equals to 9a e power minus 3x plus 4b e power 2x. Okay, I'll give you a simple method how to do for this problem. Here, is it are we able to eliminate one arbitrary constant, either a or b, when we made one-time differentiation? Yes or no? ఒకసారి differentiate చేసినప్పుడు eliminate చేయగలిగామా a గాని b గాని? No, we are unable to eliminate it. When we do the second time differentiation, we eliminated at least one. No. So in this case, only because of this reason, I mentioned in the procedure, while we do the first time differentiation, we don't know which arbitrary constant will eliminated or not. That we cannot write. Okay, so that I have written only C1, C2 and so on Cn. Second time, third term, all the times I have written C1, C2 and so on Cn. That I don't know. That means we cannot say when we do one time differentiation, one arbitrary constant will be eliminated or not. That we cannot identify. It totally depends upon the problem. Clear? So now how to do our problem is, in a simple manner is, I'll give you technique. This technique is applicable only for the function is, okay, whenever the given function contains only two arbitrary constants. Whenever the function contains only two arbitrary constants, then only it is possible. The procedure which I am explaining. Now, for the namesake, I am writing here because it is not visible. What is a given function y? Y is equals to a into e power minus 3x plus b into e power 2x. Now, I am going to take, if it is two arbitrary constants, then try to take 3 by 3 determinant. 3 by 3 determinant. Now here I am taking a coefficient, b coefficient, the constant term which is not having a and b. Okay, which is not having a and b. Clear? What is the a coefficient in the first equation? This is the equation number 1. What is a coefficient here? What is a coefficient?
1.
E power minus 3.
Yes, e power minus 3x is a coefficient. I am asking about, we are going to discuss about for formation of ordinary differential equation when they provided two arbitrary constant and we are unable to eliminate after doing two times differentiation. We are unable to eliminate at least one arbitrary constant also. Then you can use this procedure. Then I am taking a coefficients, b coefficient, and other than a b coefficient. What is a coefficient here? E power minus 3x. I am taking that. What is a b coefficient in the same equation? E power 2x. What is the term which do not contain a and b in that equation? Bring this y also to right hand side. If we bring y also to left hand side, what is going to become? Minus y. So we have to take it as minus y. Okay. Then going to the second equation. What is the second equation? A coefficient is how much? What is a coefficient?
E power minus 3.
Minus 3 into e power minus 3.
Minus 3 e power minus 3x. Minus 3 e power minus 3x. What is the b coefficient in the second equation?
2 e power 2x.
2 e power 2x.
2 into e power 2x. What is the term which do not contain ab? Y dash. But that y dash we must take to right hand side. What we are going to get? Minus y dash. Okay, this is mandatory. Next, third equation. In the third equation, what is a coefficient?
9
9
e power
into
3.
e power minus 3x. What is a b coefficient? 4 into e power.
4 e power 3.
What is the term which do not contain a and b? Y dash. That y dash we have to take to right hand side. It will become minus y double dash. Okay. Then take the determinant of this and equate to 0. This is a technique. Take determinant of this is equals to 0. So I am just rounding like this. Understood how we have taken? Then find the determinant of this. While finding the determinant of this, if you observe, what is the first column contains the common? First column contains
E
E power minus 3x.
e power minus 3x. I am taking common. And same manner, what is the second column contains?
e power
E
2x.
power
E power
2x.
2x. Then can I take common like this? Yes or no? Yes, we can take. No problem at all. In the third column, what we can take common? Minus 1 common.
Minus.
1 common. So we'll get 1 minus 3 and 9. 1, 2, 4, y, y dash, y double dash. Now that implies minus e power minus x, e power minus x into e power 2x, e power minus x into, find the determinant of this 3 by 3 matrix. While we find the determinant of this 3 by 3 matrix, you wish you can take along first first row, second row, third row, or first column, second column, third column, but I'm finding it along the third column because we required y dash, y double dash, and so on. All these remaining elements are constant, so we will get it easily if we do it like this. So y into what is we have to take here? It is positive, negative, positive. So positive will get here negative, positive, negative, positive, negative, positive. So I'm just concentrating on that positive, negative, and positive. I'm not writing the remaining things. I erased all the remaining things. Y into what is the determinant of remaining part? Eliminate this first row and third column elements. How to eliminate? Eliminate this first row and third column because corresponding to y. So what is the determinant of this one? So I'm writing it
-30.
minus 3. Okay. Minus 3, 2, 9, and 4.
-30.
Minus y dash into minus y dash into. Now we are finding determinant along y dash. That means which elements we have to eliminate? This is in the first, second row, third column. So eliminate second row and third column elements, then find the determinant of 1, 1, 9, 4. 1, 1, 9, 4 plus y double dash into. Next, we have to eliminate, okay, y triple dash. Sorry. Y double dash. What is a y double dash into? We have y double dash is in third row, third column. So eliminate third row, third column elements. Then we can take the determinant of rest of the part 1, 1, minus 3, and 2. And as usual equate to 0. Then that implies minus e power minus x into what we'll get? Minus 12
-30y.
minus
minus 18
18. Minus 12 minus 18 is
minus 30
minus 30y minus y dash into 4 minus 9 minus 5 plus y double dash into 2 plus 3 is 5 is equals to 0. Then if we do the simplification, now tell me here what is either minus e power minus x is 0 or this one is 0. What is that one? Minus 30y plus 5y dash plus 5y double dash equals to 0. So from this, can I take 5 common and can I take it to right hand side? Then I'm writing with the higher order first. Y double dash plus y dash minus 6y equals to 0. Now this is our, in this equation, do we have the arbitrary constants a and b? Yes
No,
or no?
sir.
No. So is required ODE of given d. A given function is required ODE of ordinary differential equation of a given function. Given function. This is the thing. Okay. When we what is the thing we have taken? When we have to take this procedure, we have to take determinant of 3 by 3 matrix equals to 0 only whenever if the given differential given function contains only 2 arbitrary constants, and while we differentiated 2 times successively, even though at least one of the arbitrary constants not eliminated, in that case we have to do the same process. Clear? Now I'm going to take a little bit critical case. Whenever we are having more than 2 arbitrary constants like this, The third problem is like this. Y is equals to a into e power x plus b into e power 2x plus c into e power 3x, where a, b, c are arbitrary constants. Where a, b, c are arbitrary constants. Now, how many number of arbitrary constants are there?
3.
3. So how many number of times we have to differentiate?
3.
So I am writing direct step. Differentiate equation 1 with respect to x 3 times successively. Because we are having 3 arbitrary constants. Okay. So when we do one-time differentiation, what we are going to get? Y dash equals to a into e power x plus b into, what is the differentiation of e power to x? 2e power 2x plus c into, differentiation of e power 3x is 3 into e power 3x. But we have to take it as equation number 1, sorry, equation number 2. But before I am going to write it as equation number 2, can I write like this? A into e power x plus, I'm writing it is as b into e power 2x plus b into e power 2x plus, can I write this 3c e power 3x as c e power 3x plus 2c e power 3x? Yes or no? So I separated this term like this and this term like this. Okay, so can we write like that or not?
Yes.
Now
Yes.
I am underlining from these 3 terms what we can write. From these 3 terms what we
Y
can
dash.
write.
Y.
Check it. Y we can write. Y we can write. We can write as y. So writing it is as, that implies y dash equals to y plus, what is the remaining terms? b power 2x plus 2c power 3x. Now taking it as equation number 2. Okay, before I am going to take as equation number 2, I am rewriting like this. That implies y dash minus y equals to b power 2x plus 2c power 3x. Equation number 2. So how many arbitrary constants are there now? 2. One arbitrary
2.
constant we tried to eliminate it. So again differentiate. Again differentiate. That implies what we will get if we do differentiation. Y dash differentiation is y double dash. Y differentiation is y dash. B into, what is the e power 2x differentiation? 2e power 2x plus c into 2c into e power 3x differentiation is 3e power 3x. Now we are going to get as y double dash minus y dash equals to 2b e power 2x. It's a less than 1 minute. Please rejoin if the meeting closes. 6c e power 3x. Now how we can write this? Equals to, taking 2 common, then what we'll get? b into e power 2x plus, writing 6c as 4c e power 3x plus 2c e power 3x form. From the first term 4c e power 3x, taking 2 common, then we'll get 2c e power 3x plus remaining 2c e power 3x is as usual. Understood? What is the technique I am applying here? Now what we can write here? Y double dash minus y dash equals to 2 into, what we can write here? From equation number 2, from equation number 2, we can write it is as y dash minus y. Which equation we used? Since from equation 2, I forgot to mention here in the previous step, which equation we used here? Since from equation 1. Okay, so like this we can do it. Then it will become as plus 2c e power 3x. Now, sorry, e power 3x. Now I'll bring these terms also to left hand side. What is going to become? Y double dash minus y
3y
dash minus 2y dash plus 2y is equals to 2c e power 3x. Now doing simplification, y double dash minus 3y dash plus 2y is equals to 2c e power 3x. Equation number 3. Now, how many times we made differentiation? Actually, we have to do 3 times. So this is first time. First time. Just for our understanding purpose. And this is the second time. And then third time. Well, we do this third time differentiation. Differentiate, again differentiate. With respect to same x variable. Then what we are going to get? Y triple dash minus 3y double dash plus 2y dash is equals to, how we can write 2c into, what is the differentiation of e power 3x? 3 e power 3x. But how I'm going to write it is as, I'm writing it is as 3 into 2c e power 3x. Can I write like that? So 3 into, what is the 2c e power 3x from equation number 3? Y double dash minus 3y dash plus 2y. Left hand side is as it is. Then finally, I am writing y triple dash left hand side as it is minus 3y double dash plus 2y dash. Bring the right hand side part also to left hand side. What we'll get? Minus 3y double dash minus 9y dash becomes to left hand side plus 9y dash plus 6y right hand side, bringing to left hand side minus 6y equals to 0. Then do the simplification. That implies y triple dash minus 6y double dash plus 11y dash minus 6y equals to 0. Now check it. After completion of the third term differentiation, these are required. These are equation we got. Do we have any arbitrary constant, small a, small b, small c? Yes or no? No. So is the required ODE? Is required ODE of given function. Given function. Okay, clear? So I just explained 3 different problems, but now here same manner you people do it for your practice. I'm giving few problems. Y is equals to e power x into a cos x plus b sin x. In the next class, I'll discuss if you have any doubts, where capital A, capital B are arbitrary constants. Fifth one, y is equals to a into e power x plus b into e power minus x plus x square. A, b are arbitrary constants. A comma b are arbitrary constants. Same manner, sixth one, you people has to try these other things. Ax square plus by square equals to 1, where a, b are arbitrary constants. Capital A and capital B are arbitrary constants. Okay, so like this, you try for so more number of problems, but still I'm going to discuss different type of problems. Here, if you observe 3 problems we discussed and 3 problems I given for practice. For all these 3, that means all the 6 problems, they given equation. For that equation or function, we need to find the you can write here it is as a equation or given function. ఇచ్చిన ఫంక్షన్ కి ఆర్డినరీ డిఫరెన్షియల్ ఈక్వేషన్ ఫైండ్ అవుట్ చేశాం, లేదా ఇచ్చిన ఫంక్షన్ కి ఆర్డినరీ డిఫరెన్షియల్ ఈక్వేషన్ ఫైండ్ అవుట్ చేశాం. బట్ నౌ దే ఆర్ నాట్ గోయింగ్ టు గివ్ ఎనీ ఈక్వేషన్, but still we have to find that differential equation. For example, they are asking a question like this. They are asking a question like this. Obtain, these are the second model of the differential equation. Obtain a differential equation obtain the differential equation of the family of ellipses whose axes coincide with coordinate axis and the center is at the origin. Okay, so this is your problem. If this is the problem, then how to identify that? How to identify that? How to identify the given equation? How to identify the given equation? If this is a problem, then how to identify the given equation?
Equation is family of ellipse. Equation of ellipse.
They mentioned ellipse, so we must use ellipse only. What is the general form of ellipse equation? What is the general form of ellipse equation?
X square by a square plus y square by b square.
B square equal to 1.
X square by a square plus y square by b square is equals to 1. Here,
1.
what about the a and b?
Arbitrary
constant.
Arbitrary constants. But
Constant.
here, one point you must learn is, you have to know is, now here I am taking like this x-axis and y-axis. Here I am taking x-axis and y-axis. Now we are going to draw the ellipse for this. We are going to draw the ellipse for this. I'm drawing the ellipse like this. This is one ellipse. This is one ellipse. Now I'm going to draw one more ellipse. I'm going to draw one more ellipse. That one more ellipse is, wait. Wait. It's a, okay. I'm taking here first one. This is as a first ellipse with the radius of this ellipse on along x-axis is for example some 2 units on x-axis, along y-axis radius is 1 unit. I am taking the second ellipse. This is the second ellipse. I increased a value. That means this a value. Along x-axis radius I increased. Along y-axis radius b also increased. Same manner, I am increasing the radius along x-axis, along y-axis. Then we are getting 4 different ellipses. Like this, we will get an infinite number of ellipses. Because do we know the values of a and b? Do we know the values of a and b? Yes or no? We don't know the values of a and b. So a, b are arbitrary constants. So we are getting a family of ellipses. So all these are having family. Family means infinite number of ellipses will exist like this. With on x-axis, a is the radius. Along x-axis, a is the radius. Along y-axis, b is the radius. So for all these ellipses, we are getting a arbitrary equation, which is x square by a square plus y square by b square equals to 1. Here, what we can understand, a and b are arbitrary constants. So we have to, they did not mention anywhere on the problem, a, b are arbitrary constants. We have to assume clearly a and b are arbitrary constants. So eliminate 2 arbitrary constants a and b. How many times we have to differentiate? Taking it as equation number 1. Take 2 times differentiation of equation 1 with respect to x successively. Then we'll get 2 more equations. From the given equation and the 2 more equations, from the 3 equations, we have to eliminate a and b arbitrary constants. Then we are going to get the different equation, which is called the ordinary differential equation of family of ellipses whose axis coincide with the coordinate axis and the center at is at x origin. This is the concept. Okay, so any doubts are there? If given y is equals to a by b plus x, okay, so a, b are arbitrary constants, they mentioned as usual. A, b are arbitrary constants. Then what we have to do according to our condition? 2 times we have to do partial, ordinary differentiation. So first time y dash equals to, what is the differentiation of a by b? 0 plus 1. So again differentiation, go for again differentiation, y double dash is equals to 0. So this is equation number 2 and 3. In the third equation, do we have the arbitrary constant? No. So then this is the differential equation of given equation. Don't assume that, sir, in equation number 2 itself, we are not having any arbitrary constants. So can I consider this is as arbitrary constant? Sorry, this is the ordinary differential equation of given equation? No, because as we discussed, if we have 2 arbitrary constants, the order of the differential equation must be 2. Is it in equation number 2? Order is 2? No. So we must do it. Arbitrary constants unna lekapoina 2 times differentiation cheyalsinde. Clear? I think I clarified.